Okay, guys, we're going to start working on inequalities. This is going to be the end of the packet. So, not sure if y'all ever noticed, but there's actually an S missing there. So, we're going to open up our packet to this page right here. And as you can see, I kind of already started. And then the video recorder got messed up. But there will be a test on September 9th. So, covering this packet. So basically the packet test is on September 9th, which means all assignments are due. And by September 8th. All right. Otherwise, that's it. That's the last day you get to turn in late work. All right. So when you're graphing inequalities, you need to remember that your inequality symbols are that less than, greater than, or less than and equal to, and greater than or equal to. And what these dots are is when you are graphing, you use a closed dot like this one for less than or equal to and greater than or equal to. You use an open dot like this one when you're just using less than or greater than, okay? So we're going to talk about that a little bit more. We're also going to talk about this thing called interval notation, and it's a way to write a solution to an inequality when you're using your infinity sign, your parentheses, and brackets. All right, so your parentheses indicate not included or an open circle. So I've got parentheses here, I've got these less than or greater than signs, and the open dot. So this basically, these symbols all go with each other. The brackets, though, indicate an included or a closed dot. So I've got your closed dot here, your greater than or equal to, less than or equal to, and your brackets. And these symbols all work together. So if I'm showing you x is greater than or equal to 8, I know I'm going to use a closed dot because this is the equals to sign. On a graph, I usually like to put a 0 just so I know where I'm kind of centered. The 8 is here, and I'm going to use a closed dot to indicate the 8, and I know that x has to be greater than, so all the values greater than 8. Now, in my interval notation, this number right here is going to be my lowest number. So this is my lowest number. This number here is going to be my highest number. And then I'm going to use the brackets or the parentheses to indicate whether it is included in the statement or not included. So in this case, we've got a closed dot, a greater than or equal to. That means that this equation can equal to 8. X can be 8. So we're going to use the bracket to indicate that. Now, there is no such number as infinity. Infinity is a concept, not actually a number, so that's why we use the parentheses here. In this one, I've got a is less than -1, okay? So I'm going to use an open dot. And I put the open circle on -1, and a has to be less than, so all the numbers less than -1, which means I cannot plug -1 in for a. That would not be accurate, because -1 is not less than -1, it's equal to it. So again, I put my negative infinity sign is my lowest number, comma, and then -1 is my highest number. Okay? So, and I said lowest number even though it's not really a number. You know what I mean. Follow the same rules to solve an inequality as you do an equation. So when we're solving, we're basically just going to use our inverse operations just like we do when we are solving an equation. An equation, of course, has an equal sign. An inequality, of course, has these symbols, right? And if you want to get really technical, and these signals, those 4 signals. So, and you need to make sure that you flip or change the inequality symbol when you multiply or divide by a negative number. And what that means is that if I have, for an example, negative x is greater than 4, you cannot solve that this way. You have to get rid of this negative. I don't want to know what negative x is. I want to know what x is. So I would divide by negative 1. And when I'm dividing by a negative number, I'm going to flip my sign. So here, the negatives cancel out, and I'm left with x is less than negative 4. Another way, you may not do it that way. Maybe you do it this way. What if you do it this way? Negative x greater than 4. If I multiply both sides by a negative 1, a negative times a negative is a positive. 1 times 1 is 1. So I'm left with positive x. And again, I'm multiplying by a negative 1. So I flip my sign around, and I'd get negative 4. And this works whether it's less than or greater than, less than, greater than or equal to, less than or equal to. Any type of signs, you just flip it. All right, moving on. So let's solve some of these. This one, I would not recommend that you change this to an equal sign. You just treat it like an equal sign. So you're not going to change the sign, you're going to treat it like an equal sign. So 5v plus 1 greater than 7v minus 17. Well, I still need to get my v's on one side and my constants on the other. So you can do one of two things. I can subtract 5v from both sides, and I'm going to be left with 1 greater than 2v minus 17. I'll add 17 to the other side, 18 greater than 2v. Now I'm going to divide by 2 and get 9 is greater than v. Now some people really like to have their variables on the left-hand side. You could do that too. That would work the same. In fact, let's do that because I want to show you why you flip it. So my answer is 9 is greater than v. What if we had done it the opposite way? What if we had said 5v plus 1 greater than 7v minus 17? Subtract 7v from both sides. I'd get negative 2v plus 1, negative 17. Now I've subtract 1 and get negative 18. Now I'm going to divide by a negative number. So in that case, I need to flip my sign. And notice that 9 is greater than v is the same as v is less than 9. Those are the same thing. The small arrow is pointing towards the v. The large part is at the 9. The large part's at the 9. The small part is over at the v. So just make sure that when you flip them, you're getting the same thing. So how would I graph this? Let's put my 0 here, my 9 here. So v is less than 9. I have to use an open circle because it's not equal to 9. And I'm going to graph all of the parts that are less than 9. So when I'm doing my interval notation, the lowest number is negative infinity. The highest number is 9. And since it is an open circle or a not including 9, then I'm going to use the parentheses. Okay, hopefully that is making sense. Now, we've got to, in this case, we're going to do the exact same thing. Let's do 5. So we're going to have 12p plus 52 greater than, I'm going to distribute that too. So negative 8 plus 4p, because the negative times the negative is a p. I'm not switching any signs because I haven't divided or multiplied across the inequality. Keep in mind, I'm not dividing or multiplying across the inequality. Even though I'm multiplying by a negative, it's not across the inequality. Now I'm going to subtract 4p from each side, so I'd get 8p plus 52. Then I'm going to subtract 52 from both sides, 8p. I'm subtracting, I'm not dividing or multiplying, and I'm going to get negative 60. And now I'm dividing by 8. Now I'm dividing into a negative number. That's okay. I'm not dividing by a negative number. So I'm still going to just leave that as the same. So even though up here I subtracted, I divided by a number into a negative number, none of those made my sign flip. The only thing that's going to make it is if I'm dividing or multiplying by a negative number. Now I can reduce 60 over 8 into p is greater than 4 is going to go into those evenly, negative 15 over 2. All right, well, how do you graph that? Well, I know that 15 over 2 is the same as 7.5. So if on my graph I can put 7, 8, so right here is going to be, oh wait, that's negative. Sorry. So the 8 has to go on the other side. If this is negative 8, negative 7, then negative 15 over 2 is right here. Oh, goodness gracious. And this should be an open dot because it's not equal. So I'm going to use an open circle. This is 15 over 2. And I can just go ahead and put that as that. And then I'm going to say all the numbers greater than 15 over 2. All right. And so my interval notation, my lowest value is negative 15 over 2. It does not include it. It's an open circle. It's a greater than, so I'm going to use a parenthesis. And the largest value is positive infinity. And I always use a parenthesis with positive infinity. All right. So let's go ahead and flip the page. If you want to do these, I'll just tell you this is 17/3 infinity. And this one is negative infinity 3. So if you want to work those problems and just see if you get the same answers, you can do that. Then we've got up here 7. So let's see what happens here. I've got 3 times 8x is going to give me 24x minus 27 greater than 4 times 6x is 24x. And plus 4 times 1 is 4. So I'm going to subtract 24x from both sides, and when I do that, 24x minus 24x leaves me with 0x. So that is basically, keep in mind, 0x is the same as 0. It is just 0. It is not 1x. It is 0. So please make sure you understand that. So I get negative 27 is greater than 4. Now, is negative 27 larger than 4? So at this point, we have no variables. And we have an untrue statement. When we have no variables and an untrue statement, then that means no solution. Okay, that means no number is going to make that inequality work. And the way that you write that would just be a null set or a 0 with a line through it. This is a null set. All right, now let's move on to number 10. We're going to distribute. Negative 3 times 2p is going to give me negative 6p. Minus negative 3 times 8 is negative 24. Negative 4 times 2p is negative 8p. And negative 4 times positive 6 is negative 24. All right, so I'm going to add 8p to both sides, and I'm going to get 2p minus 24 greater than negative 24. Now I'm going to add 24 to both sides, and look at this. Plus 24 plus 24, and I get 2p is less than 0. Now, we have a variable. So, if we have a variable, it means that this is not over. We can still solve this. Do not stop here, because that'll be wrong. I'm going to divide both sides by 2, and I'm going to be ending up with p is less than 0 over 2 is 0. This is my solution. I have one solution. So, just keep in mind that if you have a variable, then you can keep going. Up here, our variables they had the same coefficient, so they were eliminated. At this point, I still have a variable. So when I'm here, I'm going to say, okay, p is less than 0, so I'm going to mark my 0 here. I'm going to use an open circle because that's a less than, not less than or equal to. And p has to be less than that, so I'm going to shade all of this that way. So to write it in interval notation, I'm going to go negative infinity with my parentheses, and 0 also with my parentheses because it's not equal to it. All right. And let's do, we haven't done any that have been equal to. If you want to do this one's going to be 1 infinity like this. So see if you can work that one out. But I want to do this one. This is 11x minus 4 greater or less than or equal to 6x minus 3 plus 5x. And the way I get that plus 5x is because I'm multiplying everything by negative 1. Negative 1 times 3 is negative 3. Negative 1 times negative 5 is positive 5x. So now I'm going to combine my like terms. And I'm going to get 11x minus 4 is less than or equal to 11x minus 3. So then I'm going to subtract 11x from both sides. And I'm going to get 0, 0x, 0x, which is 0. So I get negative 4 is less than or equal to negative 3. Now we've got no variables. So you're going to write no solution, and then it's going to be wrong. Why would that be wrong? And the reason is because is negative 4 less than or equal to negative 3? And the answer is yes. Negative 4 is less than negative 3. So we have a true statement. All right. Up here was an untrue statement. So that gave us a no solution. Here we have a true statement. So that's going to give us infinite solutions. No matter what number we put in there. And so to graph that, you literally would just shade in the entire thing. This is also all real numbers, but the way to write it in interval notation, you just do negative infinity is the lowest, and positive infinity is the highest. Okay? All right. Now, set notation, just for your information, is if you were given this x is greater than 5, in set notation you would write it as x is the set of numbers where x is greater than 5. And that's how you would write that. So you'd say x is the set of values where x is greater than 5. All right. So we'll stop this video here, and the next video we'll go on to the last set of notes. Okay, guys.